Yeah, this is also a live project called Cellu2PLA. So Cellu stands for cellulose, and we try to convert it to PLA. PLA stands for polylactic acid, and that's a bio-based plastic. Sounds like a dirty job, but someone's got to do it. So that would be us, for example. 3 parties are working together. Hoogheemschap Hollands Noorderkwartier, it's a water board in Northern Holland. That's my employer. Yeah, we don't have to. It's not only our job to keep dry feet, living with water all around our area, but we also are responsible for cleaning up sewage from 1.4 million people. And we do that with 15 wastewater treatment plants in the area. We work together in this project with Atero. Atero is a Dutch waste management company. Well, on the map you see where they mainly are doing that work. Yeah. Yeah, they want to operate more and more sustainable, so they also try to look in the waste and find some products that they can reuse. And they are interested in our cellulose. So that's why they work together with us. And third is STOWA, our host today, the Foundation of Applied Water Research. So we work together, us 3. So why are we doing this? In the first place, it's needed because the wastewater treatment plant you see on the slide, the capacity of the wastewater treatment plant was too low. There was more and more wastewater was coming in, mainly because of the city of Purmerend is nearby. More and more houses were built, so the load of wastewater exceeded the capacity of the plant. We managed to cut off a part of the rainfall runoff, but there was still that amount of organic load we had to deal with. So how to increase the capacity of this plant? We studied about it. 5 options were set together, and also one was the finescreen option. So where you put them in front, you prevent the organic load of coming in on the actual plant, so the actual plant doesn't have to be expanded with an extra clarifier or something. So all those 5 options were set next to each other, and what are the costs? How sustainable are they? And finally, we choose the option with the fine screens. And how fine are those screens, really? Well, this is what it looks like. Very impressive, very innovative. I could think of this myself, but I didn't. Yeah, it's a grid of 0.35 millimeters, and it's put upstream of the wastewater treatment process. Almost the first step, because upstream of it you have the coarse screen. So that's vertical bars with 6 millimeter in between them. They collect the bigger parts floating in the sewage, and after that, just downstream of that, the fine screens will be installed. So that's the theory about this one. How to make it? We made a prototype, something like this. But it didn't really work out, of course. You had to hold it, and all the wastewater was all over your hands and smelled. So we improved it to something else. There was already a company who was making these fine screens. And they are already produced and also proved in Norway. There they use it for the cleaning up wastewater for smaller towns near the fjords. But then it's also the only way of, part of treating the sewage. So once it is through the fine screen, then the water will go to the fjord. But of course, that's a big water. You won't recognize any pollution anymore. But In Holland, there's a different way, because now we use the finescreens, and behind the finescreen, there's a whole biological treatment process. So that's an innovative way of using these finescreens. Yeah, well, this is what it looks like. The sewage is flowing towards the screen. It's a rotating belt, and yeah, the solid parts will stay on the screen. It will go up over the edge, and the solids will drop off on the other side into a screw conveyor, and it's yeah, moved towards a container, also dewatered in the same time, about 40% dry solid. So yeah, for us that is a success. For our water board, then our plant is expanded in capacity, and we produce along the way a new material, a new waste stream. Yeah, what to do about it? Maybe for 10 years ago we would have dried it, burn it, maybe make some energy from it. But nowadays we look different. Of course, yeah, what's in there? Maybe you can use it. And yeah, what's in there? It's mainly toilet paper, actually. About 70% of it is toilet paper. You have some organic parts, lots of hair. And this toilet paper is cellulose. And yeah, there are companies interested in that material, like Atero. Yeah, like I said, Atero, waste management company. Over 6 million people, and their waste is managed by Atero. 40% of all Dutch household waste. And more they look at ways to do something with that waste, and maybe get some energy out of it, but also separate the good materials out of it and reuse it. And they're also interested in cellulose, like from diapers or beverage cartons. And the cellulose from our sewage plants is also a waste stream that can be combined with that. So this is a sketch how they draw out the process, how to convert the cellulose to a useful product. And yeah, these steps are to finally make a sugar solution, glucose. And once you have a good glucose solution, then it's possible to make lactic acid out of it. And then you can, via polymerization, you can make a polylactic acid from it. And that's a bioplastic that can be used in various articles, like drinking cups. But maybe you will not drink out of it, but you can also make other things, maybe a holder like this one or something. Doesn't matter. That's a little bit about the process. Yeah, back to the LIFE project. Why did we subscribe for this LIFE fund? We set out a few goals. So one of them is to produce this PLA out of the cellulose from domestic wastewater. And second, we try to improve the wastewater treatment process with this finescreens. And if you really reach these goals, you have to monitor the whole process, of course. What will be the effect on the wastewater treatment plant? Well, in terms of energy use, we predict it will save us energy, because you prevent a lot of organic waste entering your actual plant. So we think in your aeration tank there will be less energy used. But on the other hand, maybe it will be worse for the conditions of your secondary sludge, because all the cellulose is behind the screens. You collected it already. It's not in your sludge anymore. So maybe the dewatering capacity of this sludge is not so good anymore. We have to find it out. We will monitor this project for 1 year. It's The building process of this plant is almost done. In July, it will be ready to collect water and to go in process. And after that, then for a year long, we will monitor the whole thing. Next is an economic analysis. Yeah, is this a cheaper way of expanding your wastewater treatment plant or not? So what's the performance of your plant? And we will make a life cycle analysis. And also for the, making your PLA from the cellulose of wastewater. Normally they make PLA out of other materials, bio-based materials like corn or sugarcane. But yeah, this is a more sustainable resource to use. So we have to calculate if it's, if it's benefitable. Is that a word? Some boundaries we see. One is the legislation, because the cellulose we collect from the wastewater, it's a wastewater stream, it's a waste stream. You make PLA out of it, but then it's still waste. You cannot put it into the market. So we have to make some steps in this legislation. And also the public acceptance, how will customers react when there's a plastic drinking cup in your supermarkets and a big sign on it, made from toilet paper out of sewage. Would you buy it? I don't know. So that you have to communicate about the project and try to sell it. Some figures, some amounts. How much do we collect? Well, here are some numbers. The screenings, sieving material. There will be 350 tons a year, dry solid. Out of that we make the glucose, and after that the PLA you can make out of it. And when you look at what when all the wastewater treatment plants in Holland, in the Netherlands, will be using finescreens, and you collect all the cellulose in them, from them, then you can make a little bit bigger, 40,000. When you do it in all of Europe, maybe 570,000. And there's also a goal set by the bio-based economy agenda that says we have to want to have 2 million tons a year of bio-based PLA. So there's still a way to go. Probably the cellulose from the wastewater will not be enough. You have to combine it with other cellulose streams like, what I said, diapers or beverage cartons or something else. But it's a start. Well, why did we go for this live fund? Actually, without a live fund, we still would have used these finescreens to expand the capacity of this of our plant. But then we would not have done anything with the cellulose stream. But now, when it's a live project, it was really a kickstart for this innovation. Like I said, we had various options to expand, to make to increase the capacity of the treatment plant. And when we were able to get this live fund for the board, it was an extra reason to choose for this option. And next, there's also exposure. The live fund gives you extra exposure. Without a live fund, I wouldn't be here talking to you. So, proof. But it's not just bragging to say, hey, look at us, we're very innovative and sustainable. But it's also, when you talk about your project, you meet other parties, and you make new contacts and maybe some new insights for the project. Last slide about lessons learned. and we have this live project. It's also obliges you to do extra things like a lot of administration. Yeah, we didn't suspect that in the beginning. We already had a Dutch fund that was with little administration when you compare with the EU Life Fund. Your whole time writing, and you have to collect the time writing signs on it. Lots of work. And also, yeah, we learned that the EU is very strict. What you write down in your proposal, yeah, they take it as like it's a Bible. What you wrote down, yeah, you have to do it. And it's very hard to make yeah, to change it afterwards. We did actually, and it took a lot of sweat, but it worked. Well, that's about this live project. Are there any questions for me?
Hello, my name is Michael Schuller from Puritech Consulting and Engineering. So what is the, how many population equivalents is the VVTP Beemster processing?
It's about 150,000. Okay. Yeah.
Next question. Next question. What do you expect about the impact of removing or pre-removing this cellulose from your VVTP? Because the organic loading will be reduced, so that is saving aeration energy.
Yeah.
You will produce less sludge, so also less biogas.
True.
What you still think it is interesting?
Yeah, we still
think
it is, and we hope, and we yeah, we're just going to monitor it. Yeah, a few plants in Holland already have finescreens, but then only a part of their waste stream is going towards that fine screen, and yeah, we are the first one to apply them in a big wastewater treatment plant, full capacity. But yeah, we are able to adjust, turn some. When it turns out that we collect too much, then yeah, we can turn off a few screens, and we will have 8 of those screens. Maybe we only want to work with 4 eventually. That's possible. That there has to be more organic waste towards the aeration tank. So that's we're gonna find it out. Keep you posted, of course.
Okay, thank you. Are there more questions for Bob about this nice initiative?
Rinus van Praag, CETIVA. What happened? You are coming in with 350 tons per year cellulose, and you're making 125 tons PLA. Yeah. What happens with the difference? And can you tell me something about the energy consumption to produce this amount of PLA? Just 2 questions.
Well, that amount of 350 tons a year, that's not just cellulose, that's the whole screening material. Yeah. And yeah, well, Atero has a process that, yeah, with enzymes, they try to convert it to a glucose solution, and then they're filtering it. So in that filter step, also an amount will stay behind. And eventually they will have, yeah, about 200 tons a year of glucose. And to make polylactic acid from it, then there's also, in that step, also a part that goes, not everything will be, yeah. And your second question was, yeah, the energy consumption of that whole process. That's, we don't know yet. Yeah, we have to find it out. From the beginning of September, they will collect our screening material, and then we'll see what happens. Yeah.
Do you expect a difference from if you would use any other waste stream for PLA production? or will it be the same?
Yeah, we hope. Yeah, we think it will be the same. Yeah, the difficult part is that the glucose solution that you make, it has to be of the same specifications as the glucose solution that they nowadays make from sugar cane and corn and that kind of materials. So once you have reached that same specification, then it's possible to make the PLA out of it. Okay.
Another question.
A short question. It took Henry about 4 years to convince his water board to invest in a live project. How many years it took you?
Well, one evening, few drinks, and it was. No, it was not so hard because yeah, even without a live fund, we would have chosen this option. So we had to expand the capacity one way or the other.
You considered 4 solutions, and then
yeah.
you selected this one with the fine screens.
Yeah.
Was the difference so enormous between all the options, or can you tell us something about more about the selection process?
Yeah, yeah. There was one other option, the Nereda process, that was very competitive with this fine screen option. Almost the same investment costs and sustainable, using less energy. But yeah, because in this way we also make way to reuse of a resource. So that's why we finally chose for this one.
So you also mentioned that if this PLA would not have been an option, that you would still go for the fine screens, yeah. And that you didn't know yet what to do with the cellulose. Were there options for other reuse possibilities?
Well, we didn't investigate that yet because Atero was already on the
doorstep.
On the horizon, yeah.
Knocking on your door.
So maybe at first we would have put it into the biogas unit. Yeah.
Okay. Well, thank you so much for your presentation.
Okay.